Alright, for number 7, you're supposed to find the values of the 6 trig functions for theta. Well, our first problem is we don't know all 3 sides. So we have to find this missing side. We're going to call this x. Okay? So we are going to refer to the Pythagorean theorem in order to accomplish this. So, Pythagorean theorem tells us that the sum of the squares of the sides of the triangle is equal to the square of the hypotenuse. In other words, x squared plus 24 squared equals 26 squared. So if I take the square root, so let's get out the calculator on this. So if I square 24, I get 576. So I have x squared plus 576, and if I square 26, I get 676. So if I subtract 576 from both sides of the equation, I wind up getting x squared is equal to 100. The way to get rid of a square, square root it. Those are inverse operations. So I square root x squared, and I square root 100, and we find out that x is equal to 10. So that is my missing side, is 10. Alright, so from the angle's perspective, then I know this is opposite. That's opposite. This side is adjacent, and this side is hypotenuse. So going through the 6 angles, sine, or the 6 trig relationships, sine is opposite over hypotenuse. So in this case, we've got 24 over 10, or excuse me, 24 over 26, which is 12/13. We have cosine of the angle, which is adjacent over hypotenuse. So we have 10/26, which is 5/13. We have tangent of theta, which is opposite over adjacent. Opposite over the adjacent, so we've got 24 over 10, which is 12/5. We have cotangent of theta, which is adjacent over opposite, which is 5/12. We have secant of theta, which is hypotenuse over adjacent. Hypotenuse over adjacent, so that is 13/5. And finally, we have cosecant of theta, which is hypotenuse over opposite, which in this case would be 13/12. And those are our 6 trig ratios for that particular triangle.